Welcome back, dear students. Today we are treating a different abstract data type known as the hash tables. Okay, a hash table, also known as a hash map, is a data structure used to implement an associative array. For those of you who are used to Python, I'm sure you know what an associative array is. An associative array is an array whereby we map key to values instead of index. That we call an associative array. Although we can still use a simple array to represent a hash table. Now, a structure to implement an associative array, a structure that can keep keys to values. That's what we say. In a normal array, we have index to values, but in an associative array, it is keys to values. A hash table is made up of two parts. An array, which is the actual table where the data to be searched is stored, and a mapping function known as the hash function, which provides a way for assigning numbers to the input data such that it can be stored at the array index corresponding to the assigned number. So it is the mapping function that does all the work in storing values. That when we have a particular value, the hash function provides a particular index based on some calculations where values are going to be stored. This is a typical example of how a hash table function. We have the different keys as you can see. They are entered inside a hash function. Then from the function now, we have this key. They are now mapped into the hash table whereby we have the value and each value corresponds to a particular key. Hash tables enable very efficient searching. In the best case, data can be retrieved from a hash table in constant time. Remember that constant time when we were doing big O notation in algorithms, we saw that constant time is the lowest possible time an algorithm can execute. So we will use them wherever high performance searching is a requirement. So remember, algorithms where high performance searching is required, it is important to use a hash table. Although there might be parameters that can constrain us to use other data structure. Maintaining, that is adding, updating and deleting data in a hash table is also very efficient. Now, a hash function. It is a mathematical formula which when applied to a key produces an integer which can be used as an index for the key in the hash table. That's how a hash function is being defined. A good hash function is essential for the effective performance of the hash table. The main requirements of a hash function are that it must always produce the same index for the same key. That is, today you are running a particular program for a particular key, it produces an index. Then the number of times you are going to use the same algorithm, it must produce the same index for the same key. The next characteristic is that it must provide a uniform distribution of hash values. That is, every value has an equal probability of being generated. The third one minimizes collision. And we are just from seeing that collision arises when many different key produces the same index. We shall evaluate this in the next lesson whereby we shall see what collision is and how to effectively handle collision in a hash table. The last characteristic of a hash function is that it should be very easy and fast to compute. There are many possible ways to construct a hash function. A common hash method is the division method given by f of key is equal to key mode m, where m is the size of the hash table. In other cases, m will be given but it will be different from the size of the hash table. But in case m is not given, you should know that m corresponds to the size of the hash table. Now, example, consider a hash table of size 10. Insert the keys as you can see into the table. Solution. Normally here they were supposed to precise that we are using this as formula. Okay, this is our hash table because if the size is 10, now the indices are from 0 to 9. We start with the first one. F of key, this is our formula because we are following this. Now, 75, F75 mod 10 gives us 5, meaning that 75 will be stored at index number 5. This is where 75 will be stored. The next, 27 mod 10, which is 7, so 27 is stored at position 7. 36 mod 10, 6. 24 mod 10, 4. Please remember, for those of you who might not understand how we are obtaining these values, Mode, we divide by 10 and we take the remainder. When you take 75 divided by 10, it gives you 7 remainder 5, as you can see. But now a general method for 10, any number in mode 10, you just take the unit position, as you can see, 5, 7, 6, 4. Very easy. But for other numbers, there are no general method. You need to divide and take the remainder. 68 in mode 10 is 8. That's where 68 will be stored. 80 in mode 10 is 0. 92 in mode 10 is 2. 101 in mode 10 is 1. So that's why 101 is going to be stored. So for these different values, if you are to insert them in a hash table, this is how our hash table is going to be. And we see that the index 3 and 9 are going to be empty. Guys, you are coming to the end of this video. I hope you have a clear understanding about hash table and how it uses a hash function to insert data. In the next video, we shall be talking about collisions, as you just saw a little. We shall be talking about collision, about the description of collision when it comes to hash table, how to effectively handle collisions, and we shall take practical examples to illustrate how these different methods of handling collision works. Thanks for watching this video. Do not forget to like, to subscribe, and to share in order for our community to grow. And why not dropping a comment which will serve as a feedback for my team and I. Thank you very much and see you in the next video.